Hello Compose enthusiasts. From rows to columns and boxes. Today we are about to get, well, lazy. When it comes to displaying lists in Jetpack Compose, LazyColumn and LazyRow are our superheroes. They are efficient, smooth, and only renders what's visible on the screen. Perfect for long lists. As the name suggests, the difference between LazyColumn and LazyRow is the orientation in which they lay out their items and scroll. LazyColumn produces a vertically scrolling list and LazyRow produces a horizontally scrolling list. So without further ado, let's get started. So for LazyColumn, we can just simply write this LazyColumn, and here we have this LazyColumn, and here let's use this items and let's provide 100 count, and we will get this index, so we will use this in placing text. Now let's run our app and see this. And just like that, we have a list of 100 items, but only the visible ones gets drawn. Scroll performance is optimized, ensuring a buttery smooth experience. Now what if we want to give some padding all around the content of our lazy column? For that, let's use these brackets, and here we have this content padding modifier. Here let's use this padding values. Let's provide 30 dp padding all around our content. So here we can see there is some padding all around our content. Now if we want to give some space in between each of these items, so for that we have this vertical arrangement parameter. So here we can use this arrangement dot space by. So here let's use this 10 dp. So with the help of this space by, each of our items will have 10 dp space in between. Let's run our app and see. So here we can see there are 10 dp space in between, and also we have this parameter called horizontal alignment. So we can align our items in three ways: center, horizontally, and start. By default it is in the start, so we can also use center horizontally. So here our items are center aligned. What more we have? We have this parameter called reverse layout, and by default the value is false. But if we make this value to true, so what it will do? Let's first see and then I will discuss. So here we can see we have our layout in the reverse order. First item is at the bottom, and when we scroll up, so we will get the last items. So when reverse layout is set to true, the order of display is reversed with items laid out bottom to top. This can be particularly useful in scenarios such as chat application, where you might want to display the latest messages at the bottom of the screen and older messages as you scroll up. Let's remove this parameter. Here in this lazy list scope, what more we have? We have this item block. If we have a single item, then we can use this item block. So here let's use a text composable function. And you are not limited to just text. You can render images, buttons, or any custom composables as list items. And we also have these items in three overloads. Like we can provide the count and this list and then array. So for now, I am using this count for this items block. So let's run our app again. So here we can see we have this new list as the first item, and then we have the list of that other items. So what more we have? So in this column we have this state. So let's use that state. So here first let's create, we have this function called remember lazy list state. We can use it to create a state, and let's attach this state with this parameter. Now with this state we can access few things, like let's use this state and place dot. So here we can access these things: first visible item index and this layout info, iteration source, first visible item scroll offset, and this can scroll backward and can scroll forward. These things we can access through the state. So let's create a simple use case of this state. What I will make a button which will be placed in this bottom right corner of the screen when the user scroll down the list, and if the list has passed the first index, then that button will show up. So for that, let's write some code. So here I have created this state show button. I am using this remember with this derived state of. And here I am checking if that first visible item index is greater than 0. If it is, it means the user has passed the first item. So first let's use a box layout that will help us placing button and that lazy column on top of one another. So here let's use this animated visibility. It will help us in making visible and invisible of that button. So here let's provide this show button. Also let's use a modifier to align that button to bottom's end. And here let's use a button. And after this button, let's use our lazy column. Now let's run our app and see this. I think I need to provide that lazy column outside that animated visibility. So let's run it again. So here we can see we have this list, and right now there is no button. But when I scroll up, so here we can see when the first item will get invisible, then that button will show up. And when we will scroll to the top, so that button will again hide. So here we can see we are using this first visible item index with the help of this state. Now if we want to apply this scroll to top functionality, so for that in this state again we have a function to that thing. So here when let's use a on click on this button, and here we can provide the index to 0. So when we click on this button, so this should scroll to the item at index 0. But right now we can see this is giving error. Why? Because this is a suspend function. It means it can only be called from coroutine. So for that, let's create a coroutine scope also. We can create a coroutine scope simply with the help of this remember coroutine scope function. Now we can run our app and see this change. So here button is not visible, but it has now Let's click on this button. So we can see it has scrolled me to the item of index 0. So what more we can do with this lazy column? We have this sticky header also in this lazy list scope. What this sticky header is? First, this is giving errors, so let's use this opt-in experimental foundation API. So it has pasted this annotation here. So let's use a text composable and let's run it. So now when we scroll this list, so we can see that heading text is stick to the top. So if we want some content to stick at the top while scrolling, we can use sticky header. You have probably seen the use of this in the contact app. Now let's create a simple contact app to see the usage of that multiple sticky headers. So for that, first let's minimize this. Let's comment out the code of this box layout, all this code, and minimize it from here. For this contact app, I have a list of that contact, this list. So I will use this list of contacts to make that simple contact app. So here let's create a lazy column. So here I have used this lazy column and I have given this content padding and this space by arrangement. And here I am using this single item of that heading contact. So here first let me create. So what this group by function will do? So this group by function will make sublist where first letter will be the key, names starting with that letter will be the values. So here we can see we have this map of key is that char first letter and that value is list of that contacts starting with that char. So here after this let's use this grouped. So here we can use sticky header and after this let's use these items block because there will be multiple items with each of that character. So here we need to use this items of list. So I have used this text composable in this first name and then last name and after that there will be phone number and there will be padding in the starting. So now let's run our app. So here we can see we have our contact app. Now let me scroll it. So here we can see that A is stick to the top until we get the B. So here we can see now B is at the top and here we have C. So this is how multiple sticky headers work. Now that list has been ended. So like this you can use these sticky headers in your use case. So we have seen that usage of that lazy column. Now we have the lazy row. First let's comment out this code and then see that lazy row. So here after this we can use that LazyRow, and here we can see items. We want 100 count, and again we can use text composable and say, and let's run our app and see. So here we can see we have this LazyRow of 100 items smoothly scrolling, and all the rest of the things are exactly similar to that lazy column. And also let's press Ctrl B to see the documentation of this LazyRow, and here we can see this LazyRow is implementing that lazy list, and that same lazy column is also implementing that lazy list under the hood, because both these things are exactly similar, only the orientation is different. Few parameters are also different, like in this lazy row we have this horizontal arrangement because the items are placed horizontally, that's why we have this horizontal arrangement, and all the rest of the things are exactly similar to that lazy column. Now let's have a look into our favorite apps to see lazy column and lazy row layout in action. We can see this YouTube app has used lazy row to place these cards at the top, and in the same way they have used lazy column to place these videos. That's our take on lazy column and lazy row in Jetpack Compose. If you appreciated this lazy approach, hit the like button and share the knowledge. Subscribe for more Compose wonders.